Here we go then. I'm in my freezing cold classroom. I'm going to record this video for you guys. I'll try and upload it on YouTube. Don't forget to subscribe. Alright, so when you look at the question 2, 7, 12, 17, ... finishes at 1, 3, 2. We want to write down the rule for u of n. So this is a step-by-step question, multi-parts. Hopefully we'll illustrate a lot of the ideas we've discussed in class over the last few weeks. Okay, so let's have a look then. Write down the rule for u of n. So you just get the formula straight out of the formula book. What is the u of n formula? Okay, so u of n is u1 plus n minus 1 times by d. So we go back to here. This is u1, and the d, can you see, is just plus 5. It's positive 5. Okay, so u of n is equal to u1, 2 plus n minus 1 times by 5 is equal to 2 plus, we expand, 5n minus 5, so this is 2 minus 5 is negative 3 plus 5n. Now of course the old method that you might still like to use, and that's absolutely fine. 2, 7, 12, you see that that's plus 5 plus 5, this is 1, 2, 3, so you know it's something linear, maybe times 5, 5 times table, then you just test it out. 3 times 5 is 15, subtract 3, 2 times 5 is 10, subtract 3, 1 times 5, subtract 3. So it would work that way. Okay, part B, find how many terms in the sequence. Okay, so the key here is that, look, you've got a rule for B. You've got the rule is negative 3 plus 5n gives you the nth term in the sequence. But now we need to look at the end part, and the end part is 1, 3, 2. So that now becomes our last term, 1, 3, 2. Okay, so we just use the rule to find out n, the number of terms, that gives us 1, 3, 2 at the end. So we just go and solve minus 3 plus 5n equals 1, 3, 2. Okay, now you guys are strong enough with your algebra to solve that, but you know, we can go here. Let me just go and put a calculator page on. And so when I'm here, I can go menu, algebra, and I will do a, well, I don't know, what should we do? Numerical solve? Things with numerical solve, it will only give us one solution. So I'm going to type in negative 3 plus 5n equals 132. And we have to type in a little multiplication here. And we have to tell the calculator what the variable is, comma, n, enter, and it's 27. Okay, but look over here, 5n equals 132 plus 5, plus 3, sorry. So 5n equals 135, n is equal to 135 divided by 5, which equals 27. Okay, so either way we get to the correct answer. Alright, let's have a little look. Part C. So this is the same sequence, but now it's been turned into a series. Okay, a series. But look, u of 1 is still 2. D here is still 5. We don't know where it ends now though, because we don't have an end point, so that's a little bit of a difference. The question is find the sum of the first 12. So remember we've got two sum formulas. S of n is u1 plus u of n times by n over 2, or S of n equals n over 2, 2u1 plus n minus 1 d. And you should have guessed the fact that because I'm identifying u1 and d, and I don't know the u of n term, still looks like a spaceship, a space, anyway, we're going to use the second formula. Alright, so let's write it down. So the sum of how many terms do we want? The sum of 12 terms is equal to 12 n over 2 into 2 times u1 plus n, 12 minus 1, times by d, the common difference, 5. Okay, and then we just crunch that out in the calculator. This is 6 into 4 plus 11 times 5. This is 6 into 4 plus 55. This is 6 times by 59, and I can do that, I think, 354. Okay, let's pause there, and then I'll do another video for the rest of it.